Two in topic 2 is using tables and graphs with sequences, and more specifically, can you tell me if it's arithmetic or geometric based off of a graph? Alright, so by the end of this objective, you should be able to A, know how to graph sequences, and then B, know how to determine whether it's arithmetic or geometric based off of the picture of the graph. Alright, so here are the 4 steps. I've labeled them A, B, C, and D that we're going to do throughout this process. Now on a test, you might not have these steps, but I just laid them out to introduce the topic itself. Alright, so if we're given a sequence, which we are, example 1, I'm going to do this one, I'm going to ask you to do very similar ones after this. I'm given the sequence 3, 6, 12, 24. I want to create a different image of this data, and so I'm going to create a table based on the sequence, alright? It's just going to help me visualize the x and y points, or the n and a sub n points, inputs and outputs. So I'm going to draw a table, have a header box of n and a sub n, and if you remember, n is my input, a sub n is my output, and just to relate this to the rest of Algebra 2, always the inputs are x's, and the outputs are y values. So I'll label that as well, just to remind myself. Going back to blue, I have 4 numbers, so I'm going to have 4 boxes. And I can assume that my first 4 inputs are 1, 2, 3, 4. Because up here, this is the first term given, the second term given, the third term given, and the fourth term given. So from there then, I can have my outputs be the actual sequence themselves. So if you can get in the habit of thinking about the sequence of given a list of numbers like that, they're technically the outputs, or the y values. So I have 3, 6, 12, and 24. I have now just created a table that helps me just look at the data a little bit differently. I can consider all of these a plotted point as well. 2, 6, 3, 12, and 4, 24. Where this is my x value, this is my y value for all the points. Again, this is just helping me get to thinking about graphing this sequence as well. So I'm going to go ahead, and again, you might not have all of these tools at your command on a test, but if you just think to remember to form a table, like I did in step A, and consider the table to be plotted points, x and y values, you'd be able to graph it pretty easily. So if I want to graph my first point, plotted point 1, 3 on the graph given to me, and this is step 2, graph the sequence. I'm going to go over to 1 on the x value, or x-axis, and up to 3. And 3 is a little bit below 5, a little bit more than half. So that's my first dot that I'm going to make, 1, 3. Then the next one is 2, 6. Input of 2, output of 6. Input of 2 up to 6, which is a little bit above 5. Right? So that's my next dot. Then 3, 12. X value of 3, y value of 12. Over to 3, up to 12, which is right about there. And then finally, 4, 24. Over to 4, up to 24, which is right below 25. I'm going to do my best, assuming we start from 0, 0 right there, to connect all of the dots. And it'll go up like so. So I have graphed the sequence. So from this basic sequence right up here, first 4 numbers, I turned it into a table with the inputs of 1, 2, 3, 4, the outputs of 3, 6, 12, 24, and then I graphed it. So that is the graph of the sequence. You should notice a couple things about it. For one, it is not a straight line, it is a curved line. And as it reads from left to right, as you go from left to right, the dots get further apart, which means it's increasing at a faster rate. So if you notice the interval of 1 to 2, the change in those dots is less than the interval of 3 to 4, the change in those dots. The interval from 3 to 4 is increasing quicker and greater. Now, step 3, I want to be able to write the explicit formula for any sequence, so I just want to continue to practice that skill. But in order to write the explicit formula, I have to determine, based off of the picture given to me, is this arithmetic or geometric? And I know that it's arithmetic or geometric based off of the common difference or the common ratio. And so up here, again, I want you to be able to tell this by the graph, and I'll get to that in just a second. But let's find if this is a common difference or a common ratio. So I'm going to go back to the original math that I've done before. I'm going to use the first two terms, and I'm going to see if it's arithmetic first, and I'll do that up here. So 6, the second term minus the first term. 6 minus 3 is 3. Check that work. Let's go to the third term, 12, and subtract the term before it, which is 6. 12 minus 6 is 6. These two are not the same. So I know that it is not arithmetic because it doesn't have a common difference if I subtract. So then let's try geometric. Let's try division. All right? I'm going to do, so this is not the same. I'm going to do then division. The second term, 6 divided by 3. 6 divided by 3 is 2. Let's move on to the third term. 12 divided by the second term, 6. 12 divided by 6 is 2. These, or this, is the same, meaning that it is geometric because I divided. So if you notice, if I start from 3 and times 2 to it, 3 times 2 is 6. Then if I do 6 times 2, it is 12, and 12 times 2 is indeed 24. So I have found the common ratio, and the common ratio is 2. All right? So that is the other piece of the information that I need to find for my explicit formula. So I'm going to write a sub n equals, the first term is always a sub 1 in my explicit formula, and the first term given is 3. So a sub 1, which is 3, times my common ratio of 2 raised to the n minus 1. Again, that's based off of the parent formula for geometric explicit formulas. So that is my explicit formula for this sequence. Now, we've already answered D. Is this an arithmetic or geometric sequence? I'm going to put that it's geometric because there's two reasons, and it says to justify your answer. So I'm going to put geometric because, please write in complete sentences. We need to get in the habit of doing that. Geometric because it has a common ratio of 3. But remember, at the beginning of this objective, I stated the main purpose of this objective is to be able to tell me if it's arithmetic or geometric based off of the graph. So I'm going to tell you now, this is the new learning for this objective, that a geometric graph is curved, like this one. All right, that is the big distinguisher. An arithmetic graph is a straight line. It is linear. All right? So geometric is a curved graph. Arithmetic is a linear graph. Geometric increases from interval to interval at a greater rate. Linear, or arithmetic, increases at the same rate between intervals because it's a line. So the other piece of information to justify this is a common ratio of 3 and, I'll make that a comma, and its graph is a curved line. So its graph is a curved line is the new learning. You need to be able to look at a graph of a sequence and tell me if it's arithmetic or geometric based off the picture. And again, arithmetic is a straight line, linear. Geometric is a curved line, exponential, or something like that. So that's the intro. That's how I would do these types of problems. I've given you one to try on your own. All right. So you're going to repeat the same process I just did. You're going to create a table. You're going to graph it. You're going to write the explicit formula. And you're going to tell me is it arithmetic or geometric. So go ahead and pause the video and try that on your own. All right. At this point, you should have tried this one on your own. Here's part A. I have created a table with my inputs 1, 2, 3, 4, and my outputs 2, 6, 18, 54. And then I have graphed the sequence right here. So you should notice right off the bat that this is a curved line. And so this is geometric. Hopefully you were able to make that connection before even finding if it has a common difference or a common ratio. Now, in order to write the explicit formula, I had to find the common difference and common ratio. And I determined it was geometric based off of the graph, so I don't even have to check to see if it's arithmetic. So if it's geometric, it's 6 divided by 2, second term divided by the first is 3. Then move on to the third term, 18 divided by the second term is also 3. That my common ratio is 3. I can use that then in my explicit formula down here, so I have a sub n equals the first term, this was a sub 1, times my r, which is 3, raised to the n minus 1. So is this arithmetic or geometric? I said it is geometric because it has a common ratio of 3 and its graph is curved. And technically this is a picture of an exponential graph. A couple reasons as to why. The variable exists in the explicit formula up here. In the powers, if you see n minus 1 is in the powers, and a curved graph like this, where if you read it left to right, it continues to go up and up forever, it's exponential. And we're going to actually do an entire module on logarithmic and exponential functions at the end of the semester. So if you did this and you got all this correct, you may move on to the practice problems. If any part of this looks different than my work here, please check with the neighbor or raise your hand and I'll check it as well.